We introduce EyeNeRF, a hybrid representation for modeling human eyes for high-quality synthesis, relighting, and animation. Deformable volumetric neural rendering techniques, such as NeRFs, enable high-quality capture of human skin and hair from sparse capture data, but they cannot model the complex appearance characteristics of eyes. Our technique combines such a representation with classical parametric shape model for an eyeball to improve the quality of synthesis. Moreover, we are also able to perform high-frequency relighting. Our model allows us to control the eye gaze and surrounding deformations consistently. To accurately synthesize novel views of a captured sequence, our hybrid representation consists of an explicit eyeball surface that reflects light outwards and camera rays inwards into the eye volume. Our deformable volumetric model also learns the scene reflectance field in the form of continuous spherical harmonics coefficients in 3D. This allows us to estimate not just scene density and depth, but also disentangle the surface albedo from diffuse and specular lighting contributions. Here, we show single-frame view synthesis results on more subjects. Note the high-quality synthesis of deformable components such as eyelashes and strong view-dependent appearance of the skin. We relight the static frames with a moving point light source. Note the high-frequency reflectance of the cornea and the strong self-shadowing effects enabled by our visibility-baked reflectance field. We can also relight the frame with changing environmental lighting at high fidelity. You can see the Grace Cathedral reflected in the subject's eyes. Our hybrid representation allows us to control the eye gaze independently while achieving photorealistic deformation of the periorbital skin and lashes. Now we show synthesis, relighting, and animation being controlled simultaneously. Note the high quality of intrinsic decomposition that our technique achieves, even for highly textured regions such as the iris, eyebrows, and skin. We now show a comparison of EyeNeRF's synthesized animation against a captured test sequence. Note that our synthesized sequence closely mimics the ground truth. Our method enables subtle control over the eyeball motion and generates consistent deformation of the eyelid and other periocular muscles. We also show a comparison of our relighting capability over a motion sequence against a ground truth test capture. Note again the high fidelity of synthesis from novel face poses and the resulting soft and hard shadows and specularities. We show the results produced by EyeNeRF against various ablations of the method. Without the explicit eye model, the baseline method cannot model the underlying appearance of the eye. Without the stage 1, it cannot produce the reflection on the eye and introduces artifacts when relighting. The simplified version of our architecture and with the disconnect, it produces subtle artifacts around the iris and pupil when relighting. We encourage the viewer to pause and peek closer to note the subtle difference in quality of synthesis and relighting. We show a comparison against Total Relighting, the state-of-the-art portrait relighting technique trained on vast amount of high-quality light stage data. Our method generates much high-quality relighting since it models the reflections off the eyes. Note that our method estimates the underlying high-frequency reflectance of the skin, while they simply render their specular shading using a fixed Phong exponent. We also show a comparison of our method with a state-of-the-art image-based regazing technique. We show more exciting results on cinematic environmental lighting. Here, we control the gaze of the subject to follow the codes dropping into view, while the environment reflects off the eye, matrix style. This was EyeNeRF. Thank you for watching the video.